Imagine driving under the sea, surrounded by nothing but water for miles in every direction. Sounds like something out of a science fiction movie, right? Well, it's real. China has just completed one of the most ambitious infrastructure projects ever, the world's longest and deepest sea tunnel. This massive undertaking took years of planning, engineering genius, and overcoming seemingly impossible obstacles. But why did it take so long, and what makes this tunnel such a game changer? Stick around as we dive into the making of this marvel, exploring the engineering, the controversy, and how this tunnel is changing the game for global infrastructure. Let's start with where this incredible tunnel is. This is no small local project. It's located in one of China's most strategically important areas, connecting Jiaxing to Ningbo, cities on the eastern coast. The tunnel runs under the Hangzhou Bay, creating a direct route across a body of water that was previously a major barrier to traffic. The need for the tunnel became apparent as the region grew. Traffic jams were common, and the old ways of getting across just couldn't keep up with the demands of a booming economy and expanding population. The sea tunnel provides an efficient and much-needed alternative, cutting down travel time dramatically and linking two critical hubs. It's not just about convenience. This tunnel will fuel economic growth, trade, and tourism for the entire region, improving the lives of millions. This project is part of China's broader ambition to push the limits of modern engineering, integrating it into the country's vast transport network. With the country's massive development plans and its drive to stay competitive on the global stage, this tunnel helps make a bold statement. China is ready to lead in cutting-edge infrastructure. But that's not all. It's just one part of a larger vision to transform how goods, services, and people move across the nation and even beyond. This tunnel sets a new precedent for what's possible. The story of the sea tunnel isn't just about digging through rock and water. It's a tale of political will, ambition, and endless obstacles. The idea was born years ago, around the early 2000s, but it wasn't until much later that the first real steps were taken. The Chinese government saw this project as vital to the region's development, so the green light was given, but not without challenges. Planning took years as engineers had to consider every possible risk, from seismic activity to extreme weather conditions, and, of course, the environmental impact of such a massive construction under the sea. Construction began in earnest in 2009, but not without its own delays. A project of this scale needed massive funding, government support, and a steady stream of resources. The real work didn't start to show results until 2014. At that point, major tunneling machinery started being deployed, and the tunnel began to take shape. But the pace of progress was far from smooth. It wasn't until the mid-2010s that things really kicked into high gear. Funding was secured, and new technology allowed workers to push forward. By 2020, the bulk of the tunnel was in place, but even then, many doubted whether it could be completed on schedule. Now, here's where the story gets interesting. China's ability to turn a massive delay into a victory. Despite all the obstacles, and with technological and logistical innovations, the project was finally completed in 2022. But what exactly were the hurdles that almost derailed the whole thing? Well, that's where the real challenges lay. If you're enjoying this deep dive into China's sea tunnel and want to see more incredible infrastructure stories like this, don't forget to hit that like button and subscribe. It helps us bring you more amazing content from around the world. Stay tuned because you won't want to miss what's coming next. Building a tunnel under the sea sounds like a simple idea, but once you factor in the real-world conditions, it becomes anything but. The first major hurdle faced by engineers was the pressure. As the tunnel bored deeper into the seabed, the weight of the water above created immense pressure. To give you an idea, it's like placing a large truck on top of a piece of paper and expecting it to stay intact. The engineers had to design the tunnel's structure to withstand these massive forces, without cracking or collapsing. The materials used had to be incredibly durable, and the construction methods were tested again and again to ensure they could stand up to the harsh underwater conditions. Next came flooding. With water constantly pushing against the tunnel's walls, flooding was a constant threat. Engineers had to be innovative, creating advanced drainage systems to keep the tunnel dry while still allowing for progress. Even more challenging was the unpredictable weather. The sea is never calm, and storms can cause severe delays, especially when water levels rise unexpectedly. In 2018, for example, flooding temporarily halted construction as the water levels surged, and workers had to step back while the problem was addressed. And then there was the earthquake risk. The region around Hangzhou Bay is seismically active, meaning that the tunnel had to be built with extra earthquake-resistant measures. The materials used needed to be flexible yet strong enough to withstand tremors, preventing cracks from forming or the tunnel from shifting out of alignment. These were not just technical challenges, they were critical to the project's safety, both during construction and for the decades to come. One of the most fascinating aspects of this sea tunnel is the technology behind its creation, especially the massive tunnel boring machines, TBMs, used. These behemoth machines are a marvel of engineering in their own right. Each one weighed hundreds of tons, and their rotating heads were equipped with powerful cutting tools, designed to slice through solid rock and soft, shifting seabed. But don't be fooled, because these machines were large doesn't mean they were simple. Far from it. These machines were highly specialized and custom designed for the underwater conditions they would face. The TBMs worked tirelessly, churning through the earth at a steady pace, inch by inch. They didn't just dig, they also installed the tunnel's walls as they moved, creating a continuous reinforced structure behind them. The machines had to be incredibly precise, and one of the key challenges was the variability of the seabed. In some places, the ground was soft and muddy, while in others, it was dense rock. The TBMs had to be able to adjust their operations based on the material they were cutting through, requiring constant monitoring and fine-tuning. Despite their advanced design, operating these machines wasn't easy. The workers inside had to deal with cramped conditions, constant vibrations, and extreme temperatures. Yet they kept pushing forward, using the best available technology to maintain the tunnel's pace. It's not just about how much they can dig, but also how efficiently they can keep the machine running. The TBMs were a perfect example of how technology can push the boundaries of what's possible in construction, allowing workers to reach goals that were once considered impossible. Building a sea tunnel is as risky as it sounds. Workers involved in the project faced dangers few others could imagine, working under enormous pressure, with the constant threat of flooding, unstable ground, and extreme working conditions. For those brave enough to take on this challenge, safety was paramount, and strict protocols were put in place to keep them safe throughout the process. The workers faced grueling hours and physically demanding labor. Many of them worked in cramped conditions inside the tunnel boring machines, enduring high heat, intense humidity, and the never-ending noise of the machinery as it powered through rock. But despite these hardships, the project was designed to prioritize safety at all costs. Each worker underwent extensive training, not just on how to operate the machinery, but also on emergency protocols in case of flooding, collapse, or fire. To make sure the workers' health and safety were constantly monitored, a network of sensors and cameras was installed throughout the tunnel. These sensors could detect changes in pressure, temperature, and air quality, ensuring that the tunnel remains safe for those inside. Furthermore, regular evacuation drills were conducted, and each worker was equipped with protective gear, including helmets, life jackets, and emergency breathing equipment. Despite the challenges, these safety measures helped ensure that the workers could carry out the project without catastrophic accidents, proving that human ingenuity could conquer the toughest environments. When you think of sea tunnels, you might imagine the famous Channel Tunnel linking the UK and France, or the Gotthard Base Tunnel in Switzerland. But China's sea tunnel is a different beast altogether. The scale of this project, both in terms of size and ambition, places it on a whole new level of engineering marvels. For starters, this tunnel is not just long, it's also incredibly deep, cutting through thick layers of rock beneath the Hangzhou Bay, where seismic activity and underwater pressure presented unique challenges that other tunnels didn't face to the same extent. Take the Channel Tunnel, for example. While impressive, it runs through a much shallower section of the sea. The technology used in that tunnel doesn't quite compare to the innovations in China's sea tunnel, especially when you consider the extraordinary depth and underwater conditions faced here. Similarly, the Gothard Base Tunnel, the world's longest railway tunnel, is a true engineering feat in its own right, but it doesn't deal with the same environmental challenges as an undersea passage. China's tunnel stands apart because of its strategic importance for the region. It's a game-changer for the way traffic and goods are transported along China's eastern coast, reducing travel time and easing congestion between critical economic zones. This tunnel sets a new standard for tunnel construction, not just in size, but also in how future sea tunnels may be built, influenced by the cutting-edge techniques pioneered here. This sea tunnel isn't just an impressive feat of engineering, it's a catalyst for economic transformation in the region. By connecting two of China's most important cities, Jiaxing and Ningbo, the tunnel plays a crucial role in boosting the economic development of the entire eastern coastal region. Before the tunnel, congestion and delays on the existing bridges and roads meant that transporting goods and people across the Hangzhou Bay was time-consuming and inefficient. With a new tunnel in place, travel time is slashed significantly, which opens up faster routes for goods to move between these two economic powerhouses. This is especially important for Ningbo, one of China's busiest ports. The increased flow of goods will ease the pressure on other transport systems and help local industries keep up with demand. For Jiaxing, the benefits are even clearer. As the city becomes more connected, businesses are better positioned to tap into the larger markets in Ningbo and beyond, driving local growth and creating new job opportunities. Moreover, the improved infrastructure means that the region is now better positioned to attract foreign investment. The ability to move products efficiently between key commercial hubs makes it a much more attractive place for global companies looking to set up operations. In the long run, this tunnel will not only help local economies thrive, but will also strengthen China's position on the global trade stage, boosting national growth and development. No massive project comes without its share of controversy, and China's sea tunnel is no exception. While it's being hailed as an engineering marvel, the tunnel's construction has faced significant criticism, particularly regarding its enormous cost and the environmental impact. The total cost of the project exceeded expectations, with some reports stating that it ballooned well beyond initial estimates, sparking debates about whether such an expensive project was justified, especially considering the region's already existing infrastructure. Critics argue that the funds could have been better spent on other pressing issues, such as improving rural infrastructure, healthcare, or education. The environmental impact was another major concern. While the tunnel itself is an impressive achievement, the process of constructing it, particularly the excavation of marine sediments and disruption of marine life, raised eyebrows among environmentalists. There were fears that the project could have long-term ecological consequences, especially in such a sensitive underwater ecosystem. However, supporters of the tunnel argue that the benefits far outweigh the costs. The improved efficiency in transportation, the potential for increased trade, and the long-term economic boost to the region all make the investment worthwhile. Plus, the tunnel represents China's determination to lead in infrastructure innovation, making it not just a local development, but a symbol of global ambition. As the tunnel continues to prove its value by transforming regional economies, it seems that the critics' concerns may gradually be overshadowed by the undeniable impact of this massive project. With the successful completion of this sea tunnel, China is leading the way in tunnel construction technology, setting a precedent for future projects both at home and abroad. The technologies developed during this project, especially those used for underwater tunneling in challenging environments, will no doubt inspire similar projects around the world. The ability to build tunnels under the sea with such precision, resilience, and speed opens the door for similar undertakings in other coastal regions, where infrastructure is a critical need. The Chinese sea tunnel has already sparked interest in countries like Japan, South Korea, and even European nations, where coastal and island connections could be transformed with similar technology. These countries are exploring the possibility of using China's innovations to address their own traffic, trade, and infrastructure challenges. In the coming years, we could see more undersea tunnels pop up across the globe, connecting regions that were once isolated due to natural barriers. The technology developed for this tunnel may also be applied to other industries. For example, the same techniques used to overcome extreme pressure and flooding could be used in other large-scale construction projects, such as underground cities, long-distance pipelines, or even future Mars colonization efforts. The sky, or rather the sea, is no longer the limit for what can be achieved with advanced tunnel engineering. The future is wide open, and China's sea tunnel is just the beginning. As we've seen, the success of China's Hangzhou Bay Tunnel is setting the stage for even more groundbreaking projects. This technology could redefine how we approach underwater infrastructure worldwide. I booked my last trip to Cancun for half the usual price. And no, I'm not gatekeeping. I used Expedia, and I've got an affiliate link below that gets you the same deals. No extra cost to you, just real savings. I'm really grateful for your time and attention. I spend hours curating the best information possible for you and presenting it in an entertaining way. If you appreciate that, it would be awesome if you could buy me a coffee so I can caffeine up and keep making great videos like this. If you enjoyed this video, don't forget to hit the like button and subscribe for more incredible stories.